Welcome back to another video about embedded system. In this video, I will introduce the pole and the interrupt mode in the embedded system on chip with our Zynq chip and pin board. And this is in order to know what is the hardware design. First, we need to go from the software design flow, go from the idea, the concept of the program that we want to design, from which we can somehow understand and determine what are the hardware components that we need to design for our Zynq chip. But of course, before watching this pole and the interrupt mode, please watching my previous videos about embedded system on chip part 1, 2, 3 and 4, because it introduces many important concepts when we work with the embedded system, like the environment Vivado, the environment SDK, hardware design, software design. So please watch them before watch this pole and the interrupt video. So now let's go back to our focus. So today is about the pole and the interrupt mode, and this is the pole mode. So in the pole mode, this is how our main program looks like. Our main program, if we write a C code, we will have the function int main. So this is the content of the int main. We will call it main program. And in the main program, we want to set up our XPLANATION with the LEDs and the switches. Now we want to have the LEDs and the switches, and then we will have an infinite loop. In that infinite loop, we will do two tasks. The first task is we will direct the switch directly to read the value from the switches in, and then we will blink our LED pattern according to the read-in value of the switch 5 times. After we blink 5 times of the LED pattern according to the switch read-in value, we will move to the second task, which is blink our fourth LED. And after that, we will continue this two tasks again. That's the software flow of the pole mode. And then here comes the software flow of the interrupt mode. Again, when we say about the main program, it means everything inside this flowchart will be the content of our int main in the C code. And anything somehow outside, it won't be inside the int main, but it will be in the same file of the int main. I will demonstrate it in the code in the SDK after the hardware design. So at the moment, please just accept them like this. So everything here belonging to the int main content. Everything outside this flow, so for example here, is outside the int main. However, both of them belong to the same file C. So now, what will be the difference between the pole mode and the interrupt mode? In the pole mode, we want to blink the LED pattern according to the read-in switch 5 times inside our main program. However, if you look here in the flow, you won't see that we will do this task in the flow. There's no place that we do the task of blinking the LED according to the read-in switch value in the main program. However, with the interrupt mode, we will be able to do this task, even though this task, this function is defined outside our main program, outside our int main. And thanks to the interrupt, so of course we need to set up the interrupt service, and then we won't ask our switches. Inside the main program, we won't ask the switches value, read in the switches value, and then blink the LED. No, we don't do that. We just keep going on to blink the fourth LED, and then we check some shared variable and we do something else. However, because we set up the interrupt service for our main program and the switches, so whenever we switch or whenever we change the position of the switch, there will be an interrupt signal sent to our main program, our file here, sent to our file here, and then the main program will detect that signal. It will detect this signal, for example, when the main program is already inside this loop of execution. Then it detects the interrupt signal from the switches. There can be 3 scenarios that it will detect the interrupt signal. For example, here in this flow, maybe there will be interrupt signal comes in, and then the main program will have to service that. So let's say we have 3 scenarios, 1, 2, and 3. 3 scenarios where the interrupt signal can interrupt our execution flow in the main program. So let's take one scenario as one example. Let's say the example of the scenario number 1. So when we are doing this flow, and then there's one interrupt signal from the switch come in inside our main program. We will stop from here, and then we direct the main program to the interrupt function, and the interrupt function will direct to the task of reading the switch value and playing the LED patterns according to the switch value. And then it ends. Sorry, I made a mistake here. Actually, it should be the end, not the start. So start and then it end. And when the interrupt service end here, it will return back to the flow of the main flow and goes to the main flow in the main program. Another example. Assume that the interrupt happens in the scenario number 2 instead of number 1. So the interrupt signal doesn't come in this flow. We'll blink the 4th LED, and then here comes the interrupt signal happens. And when the interrupt signal happens from which is generated by the changing in the switch, we will stop our main program flow here, and then we direct the main program to the interrupt function. And again, when we are inside the interrupt function, we will read in the switch button, and then we will blink our LED pattern according to the switch value, and then we end the interrupt. We end the interrupt, and then we go back to the main flow of our main program, and then we continue our main flow in the main program. So that's the concept that we want to do in order to see the difference between the pole mode and the interrupt mode. So in the pole mode, we will ask the value from the switches and also blink the LEDs inside our main program. However, in the interrupt mode, we don't do that task inside the main program. We will only do that task when there's an interrupt from the switches happens. Then we will do it. So according to the software idea of both the pole and the interrupt mode required more services. So for sure in the hardware design, there will be more components required. When we work with Vivado, the step takes a lot of time is when we generate the bitstream of the hardware design. So to avoid wasting time, we need to design our hardware for the more complex software idea. So if we compare between the interrupt mode software idea and the pole mode software idea, we can clearly see that the interrupt mode is more complex. As a result, we just need to design our hardware to satisfy the interrupt mode software. When the hardware can support the interrupt mode, for sure that hardware can also support the software for the pole mode. From that conclusion, we come to the block diagram of a hardware design. So everything we can design here will be inside our Zynq chip. We will design it with the supported from the Vivado, and when we design the hardware diagram in Vivado, finish it, we can do the software program development in the SDK generated based on our hardware design. So inside our Zynq chip, we have 2 main domains, the processing system and the programmable logic. And in the processing system, we will create a block named processing system block, and in the programmable logic, we just need one block, which is the XRGBL 0, and we will config the XRGB 0 to connect to the 4 LEDs and the 2 switches. And because we want to use this hardware design for both software development code of the poll mode and the interrupt mode, that's why we will need to set up the interrupt, even though in the poll mode we won't use this interrupt port, or we won't use this interrupt path signal connection between the XRTVL to the processing system, but we just set it up in case that we want to use the interrupt mode software. So with this hardware diagram, we can start to design our hardware in Vivado. Now I already opened the Vivado. We can create a project. We create new. And then next we can choose a location for the project. I didn't use my C drive. I used a T drive, which is not my main drive. However, Vivado can still support any project outside the main drive, so I would use my G. But don't do the directory too long. I think one layer of directory like this is already enough. And then we will put in our poll interrupt hardware design project, and we create the subdirectory inside the folder in order to distinguish this project with another project. And we click next to choose RTL project as we introduced earlier, and we add no sources since we will build the hardware design from scratch. And the target language is Verilog, and simulator language is mixed. Mixed means mixed between Verilog and VHDL. Next, and for the constraints, we don't have any constraints in this case because Vivado already in another version, updated version, so we don't need to add a constraint in this case. We just need to add the board, and our board is pink. This one, and we choose it, and we finish. And then we wait until the Vivado open the new project for us to handle. Okay, so now this is the project. Let's create a block design, and we rename it. And then we wait again. We will build our hardware design based on what we have introduced at the beginning of the video of our project. So the first block that we need is the processing system. Then we wait. Now we got the processing system. We run the block automation so that it can reset the processing system block and do the default configuration. So now it looks good. Then we add the XRGBL. Okay, now let's add. So the port 1 we can connect to the LEDs, and the port 2 we can connect to, let's say, I think I would like to connect to a switch. Let's say I would like to connect to a switch. You can connect the LED to the port 2 and the switch to the port 1, or to the interface or to the channel. I mean, interface, port and channel, they are the same equivalent in this case. You can switch the position. However, when you switch the position of the channel, different from what I'm doing in my schematic, then you need to do some modification in the code in order to make it work properly. So if you don't want to go through the code modification when you run it, so just follow what I'm doing now, so you don't have to modify the code when you have not understood everything in the code. Okay, so again, the port 1 connected to LEDs 4 bit, the port 2 connected to the switch 2 bits. 4 bit because we have 4 LEDs, so 1 bit, 1 LED. 2 bit because we have 2 switches, so 1 bit represents 1 switch. And I will click OK. And we run connection automation. We choose all of this connection, GPIO 0 to LEDs 4 bit, GPIO port 2 to switch 2 bits, yes, and the slave XI, yes. The slave XI is here. So let's open it. You can choose optimize routing, and here is our block. So you can see our XI GPIO, and this is the connection of the XI connection. And this XI connection is connected to this box, and this box is connected to this port of the processing system. This is the port the processing system will send a lot of things to our XI GPIO in order to command our LED, or to command the switch, or to read some information from the switch back. So this interface is the connection between our XI GPIO and the processing system, which is the XI interface. And because we want to demonstrate 2 modes, the pole mode and the interrupt mode, so in the pole mode we don't need to have further design in our hardware, but for the interrupt we need to enable the interrupt in the XI GPIO and also the interrupt in the processing system in order to enable the interrupt function in the processing system. So if we compare between the hardware design or pole mode and the hardware design of the interrupt mode requires more. And you know, when we generate a bit stream of the hardware design, it takes time. So we need to consider what design will require more hardware components and choose it, design that more complex hardware design, and then we generate the bit stream. With that more complex hardware design, we can do both pole mode and interrupt mode coding for the same hardware design. However, if we choose the simpler hardware design and then we generate the bit stream, in this case we can only run the pole mode in the code with the hardware design, and interrupt mode would not be possible to be implemented in that simpler schematic hardware. As a result, we will enable the interrupt in the XI GPIO. We go to IP configuration, and here is the enable interrupt. We click OK, and you see there's a port interrupt added to our block XI GPIO, and also we need to enable the interrupt in our processing system. Double click and we choose interrupts, and we choose fabric interrupts, and because we're gonna receive the interrupt signal, we see that we're gonna receive the interrupt signal from the XI GPIO, and then we process that signal. We don't send any interrupt signal from the processing system to the XI GPIO. So in that case, the direction of the interrupt signal is sent from the XI GPIO to the processing system. In other words, from the PL, programmable logic domain, to the PS, the processing system domain. That's why we need to choose PL to PS for our signal in this project. And then we choose the interrupt request signal here, we enable it. And that's everything we need, and we click OK. And now we can see there's the interrupt board added to our processing system, and we connect them manually here and here. Now everything is done. We have the XI GPIO connected to the port 1 LED, port 2 switch, and the interrupt is enabled. So it means in the code when we do coding in SDK, we can do both mode, port mode or interrupt mode. Now let's validate our design to see whether it's okay. Validation successfully is good. Next, we need to generate the HDL wrapper. We let the Vivado manage wrapper and auto update. If we choose that option, the next step, even though we're gonna add another block to the schematic or we're gonna do some different wiring, we don't need to generate our hardware wrapper, HDL wrapper again. We only generate the HDL wrapper once for the first time when we design our hardware schematic, because we already choose the option of let the Vivado auto update our HDL wrapper according to our hardware design already. So now after the HDL wrapper is generated successfully, now we can even see here in the TCL console. Next, after we done generating the HDL wrapper, we will generate the bitstream. Then we wait until the generation bitstream has been finished.